Hello friends, I Prof.Darshan B.Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head digital communication. Friends, as far as our today's session is concerned, so we will try to learn the another digital modulation scheme whose name is nothing but, as you can see, the M-Ary phase shift keying technique, or more prominently we can call it as a M-Ary PSK. So first of all, we need to understand the objective behind this M-Ary PSK. Why to go for this M-Ary PSK over the conventional digital modulation scheme whose names are nothing but what? The binary phase shift keying and the quadrature phase shift keying technique. As far as our previous two sessions are concerned, so we had discussed the basics of these two techniques. So basically, this M-Ary phase shift keying technique uses the m number of symbols for the purpose of transmission, because it is an extension of binary phase shift keying technique and the quadrature phase shift keying technique. Because see, as far as this BPSK or the QPSK is concerned, so we are very much aware of this thing. In case of binary phase shift keying technique, we are having the two different symbols with us. As far as this quadrature phase shift keying technique is concerned, so in order to furtherly improve the transmission bandwidth, or in order to effectively utilize the available transmission bandwidth, the number of symbols are being enhanced in case of quadrature phase shift keying technique. So the number of symbols in case of QPSK is 4 and the number of symbols in case of BPSK is nothing but what? 2. Now as far as the transmission bandwidth is concerned, so how this transmission bandwidth is denoted in case of this digital modulation scheme, as we had discussed in earlier lecture, so which exactly equals to twice of FB upon log m, and the base of this logarithmic function is 2, right? So where as far as its denominator is concerned, m stands for what? The number of symbols adopted by that particular technique, right? So let us quickly go through in case of binary phase shift keying technique, as we are very much aware of this thing. M equals to what? 2. So this expression will become 2 FB upon log to the base of 2 followed by this 2. So log 2 to the base of 2 is exactly equals to 1. So the bandwidth of this binary phase shift keying technique is exactly equals to 2 FB, right? Similarly, in case of QPSK, if M equals to 4, or we are having the 4 different D bits in case of this quadrature phase shift keying technique, so log 4 to the base of 2 equals to 2. So it will become 2 FB upon 2. So this 2 will get cancelled. So again, as compared to the binary phase shift keying technique, in case of quadrature phase shift keying technique, the bandwidth is being minimized, which exactly equals to FB as compared to 2 FB. Now, see, whenever we are going for this M-Ary phase shift keying technique, so there are m number of symbols, right? So if suppose m equals to 8, because as far as our today's session is concerned, so we will try to learn this M-Ary PSK technique by the virtue of 8 array PSK, means 8 different symbols we do have with us, right? So let us quickly go through this bandwidth expression. When m equals to 8, so this expression will become what? 2 FB upon log to the base of 2 followed by 8. So log 8 to the base of 2 is exactly equals to how much it is? Which exactly equals to 3, right? So this expression will become 2 by 3 times of FB. So as compared to QPSK, in which the bandwidth is exactly equals to how much? It is FB. In case of binary phase shift keying, the bandwidth is exactly equals to twice of FB. So in this way, each time the transmission bandwidth is being minimized, because see, as far as these digital modulation techniques are concerned, which will try to find the application in terms of this telecom industry for the purpose of transmission of that data, whether it is in analog form or the digital form. So as far as these telecom industries are concerned, most of their investments are being engaged in order to purchase the transmission bandwidth, right? So from design or the most important role which is allocated to that design engineer is to effectively utilize the available transmission bandwidth. So in this way, we can minimize the transmission bandwidth by enhancing the number of symbols. So the overall cost against that telecom industry is being also minimized. So this is the objective behind this binary phase shift keying technique over the this is the objective of this M-Ary phase shift keying technique over the binary phase shift keying technique and the quadrature phase shift keying technique. So let us quickly go through how this M-Ary phase shift keying technique works. Means ultimately our interest is to change the phase of this unmodulated carrier signal with respect to the digital symbol sequence. But here, as the number of symbols are being enhanced, here M equals to what? For sake of this moment, M equals to 8. So this is how your 8-array PSK modulator or the transmitter will look like. Now, as we are supposed to generate the 8 different symbols, right? So these 8 different symbols are being generated with the help of finite binary bits, right? So if binary number of binary bits to generate the 8 different symbols is exactly equals to 3, means if suffix n equals to 3, n equals to 3, so the number of symbols equals to what? 2 to the power n, right? Now when n equals to 3 means 2 to the power 3, so 8 different symbols we need to generate, right? Now this is how these 8 different symbols are to be denoted with the help of 3 binary bits, because suffix n is nothing but what? The length of each and every symbol. Here suffix n equals to 3. So with the help of 3 binary bits, those 8 different symbols are being generated, and our area of interest is to transmit that data with the help of this 8-array PSK technique. Means we are supposed to modulate or we are supposed to transmit these 8 different symbols by the virtue of this M-Ary phase shift keying technique. That is our objective. So let us quickly go through how this 8-array phase shift keying modulator or the transmitter works, right? So as I told you earlier, these are the 8 different symbols which we are supposed to transmit with the help of this 8-array PSK. So as far as this modulator is concerned, so which consists of 2 identical channels, the upper one and the lower one. So as I told you earlier, each and every symbol consists of 3 binary bits. So these 3 binary bits are being furtherly categorized as a Q channel, I channel, and C stands for what? The desired carrier, right? So as we are having the 2 identical channels, the upper channel can be configured as a in-phase channel and the lower channel can be configured as a quadrature phase channel. So these 2 are nothing but what? The digital to analog converter belongs to upper channel and belongs to lower channel. Once this digital to analog converter is completed his desired work, after that we used to have these 2 product multipliers belongs to upper and lower channel, right? So as you can see, the input or the what kind of symbol is being given to this 8-array phase shift keying technique. We are supposed to transmit the 8 different symbols, and each and every symbol consists of 3 binary bits. So how these 3 binary bits are being categorized? Q, I and C, right? So initially, as you can see, this I bit is being given to the upper channel and the Q bit is being given to the lower channel. So in that first step, or in case of this transmission or the modulation process, this I and Q bits are being multiplied with this C bit, right? And after that, it is being given to the digital to analog converter. So basically, this digital to analog converter will generate the 2 different symbol sequence into that upper channel, which desired symbol sequence is being generated, this I into C, right? As far as the lower channel is concerned, so one identical inverter is being connected to the upper terminal of this lower channel. So this C is being inverted into C bar. So what kind of multiplied symbol sequence is being generated by that lower digital to analog converter? By accepting the Q bit, it will generate the desired Q into C bar, right? So these 2 signal levels are being generated by this upper and lower digital to analog converter, or we can call it as these are the 2 different levels generated by upper and lower channel, right? Now according to 2 to 4 level code converter, these 4 different symbols are being used to represent these 2 levels, right? these two levels are being represented with the help of these four different symbols, or we can call it as a D bits. So these a group of two binary bits are being used to represent these two levels which are being emitted by upper and lower channel, right? So how it is being configured according to, as I told you earlier, 2 to 4 level code converter. This 00 is being assigned with this value minus 0.541. 01 is being assigned with this minus 1.307, which is based upon the algorithm of 2 to 4 level converter. So in this way, the certain desired values are being assigned to this IC and QC bar, which are being generated by upper and lower channel. Because see, once this desired symbol sequence is being generated by this upper and lower digital to analog converter, furtherly we used to have the product modulator, or we can call it as a multiplier. So what this modulator or multiplier will try to do, it will try to suppress the desired carrier signal. So in order to suppress the carrier signal, that particular high frequency signals are being generated by this sinusoidal oscillator, which is being given to the lower terminal of this upper modulator. As far as the lower modulator or the lower multiplier is concerned, again which consists of these two identical inputs. One is modulating signal and another is nothing but what? Carrier signal. The modulating signal is nothing but what? The desired symbol sequence emitted by digital to analog converter, denoted by this Q into C bar, right? Then after that, this QC bar and this IC, these two signal levels are being multiplied with this carrier signals produced by this oscillator and produced by this 90-degree phase shifter. So as a result of this, what will happen? This oscillator will generate the two different types of carrier. One is nothing but what? The sine carrier. And when this sine carrier is being passed through this 90-degree phase shifter, obviously which will try to produce the cosine carrier. So these sine and cosine carriers are being multiplied, or we are supposed to superimpose this IC and QC bar signal levels with the help of this carrier signal to generate the modulating symbol sequence of this 8-array binary phase shift keying technique, denoted by this S of t, right? So now the question arises, how to get this S of t? So in order to generate the desired modulating symbol sequence, these two signals emitted by upper modulator and the lower modulator are being added with each other with the help of this combiner or with the help of this adder. As you can see, this here also we are having the plus, and into that lower terminal we are having the plus sign. So how to represent this desired modulated symbol sequence, denoted by this mathematical expression S of t, right? So this IC bar is being superimposed with the help of sine carrier, and IC signal level is being superimposed with the help of sine carrier, and this QC bar is being superimposed over the cosine carrier, that is nothing but what? Cos of omega ct, and sine carrier, how it is to be represented? Sine of omega ct, right? And finally these two multiplied symbol sequences are being added with each other to generate the overall modulating symbol sequence, denoted by S of t. So how it will how it is represented? In this way, IC into sine omega ct, means this IC is being superimposed with the help of the sine carrier plus QC bar into cos of omega ct. In same manner, here the QC bar is being superimposed with the help of the cosine carrier, which are to be emitted by this 90-degree phase shifter, right? So in this way, this modulating symbol sequence is being represented. Now, as we are having the 8 different symbols, each and every symbol consists of 3 bits. So according to this binary number system, in this way, these 8 symbols are being represented starting from 000 to 111. And again, as I told you earlier, these 3 bits are being categorized as a Q, I and C, where this Q and I, it will try to determine the sign of that signal, and this C will try to determine the magnitude of that signal, right? So accordingly, these 3 bits are being categorized as a Q, I and C. So initially the first symbol we are having with us is nothing but what? 3 times 0. Out of that 3 times 0, first bit can be considered as a Q, second bit can be considered as I, and third bit can be considered as a C, right? So here initially I equals to what? I equals to 0, and here Q equals to what? Q equals to, again it is 0, right? Then after that what will happen? There will be a multiplication in between this 0 and carrier, as well as 0 and C bar to generate the IC and QC bar, right? So here, as I told you earlier, I equals to 0 and C is also equals to 0. So which desired value is being assigned by the 2 to 4 level signal converter for this level, in which I equals to 0 and Q equals to 0, so, right? So for I equals to 0 and C equals to 0. So for that purpose we need to look around at these two different assigned tables, right? So in this table here, initially when I equals to 0 and C equals to 0, so which value is being assigned? Minus 0.541, right? So here I is equals to 0 and C is also equals to 0. So I is replaced by 0 and C is being replaced by 0. So this 0, 0 is being multiplied with this sign carrier, right? So which value is being assigned to this 0, 0? This minus minus 0.541 is being multiplied with this sign carrier along with this negative sign, because that negative value is being assigned, right? So in this way IC into sin of omega ct is being represented, where I equals to 0 and C equals to 0. So which value is being assigned? Minus 0.541, right? Now as far as the remaining part is concerned of that modulating symbol sequence, which consists of QC bar into cos of omega ct, right? So in that first symbol, Q is equals to 0 and C is equals to 0. So C bar means that 0 is converted into 1, right? So here Q equals to 0 and C bar equals to 1, right? So which desired value is being assigned for this 0, 1? It is minus 1.307, right? Which is multiplied with this cosine carrier which is being produced by this 90-degree phase shifter. So how to represent this overall signal when Q equals to 0, I equals to 0 and C equals to 0? It is represented in this way, minus 0.541 into sin of omega ct minus 1.307 into cos of omega ct. Now one question arises in our mind, why to go for such type of mathematical treatment? Because ultimately we are supposed to draw the constellation diagram for this 8-array phase shift keying technique. So in order to draw the constellation diagram, first of all we need to represent it how this modulating symbol sequence is being expressed with the help of these 8 different symbols by taking into account these two assigned tables with the help of 2 to 4 level code converter, right? So in this way the first symbol is being represented, right? Minus 0.541 sin omega ct into minus 1.307 cos omega ct. After that furtherly we are having these two columns, magnitude as well as phase. So we are very much aware of this thing, how to tabulate this magnitude. Magnitude is nothing but what? Square root of real part square plus imaginary part square. And how to determine this phase angle? Tan inverse of imaginary part upon real part. So in this way these two factors are being tabulated. So when we put or when we substitute the desired value of this real part as well as imaginary part or in phase channel or the quadrature phase channel, so we will come to know the magnitude of this modulated symbol is exactly equals to root 2, right? And its phase angle is exactly equals to almost 67.51 degrees. So by an amount of 67.51 degree, the phase of this unmodulated carrier signal is being changed by this 8-array PSK modulator or the 8-array PSK transmitter, right? So this is how this system works.